Good morning. Today we are going to be reviewing what we have covered so far on chapter 10, which deals with probability, permutations, combinations, and of course the binomial theorem. So we're going to go through the front page, and then your homework will be to work what's on the back. And yes, I apologize, I only gave you guys this few problems for homework. So remember that you want to make sure that you understand each of them. So I'll go through each one of them, and hopefully that will help you guys, for those of you guys that were absent due to the KC or do not understand a specific problem. So let's go and start with problem number 1. It says, now all of you guys should have a highlighter and a red pen to be able to highlight the key concepts of each problem. It says, use the binomial theorem. So we need to be able to use the binomial theorem to write the binomial expansion. We have 2x minus 3 to the 5th power. Now in order to start, we're going to use our Pascal triangle. So let's go and build the Pascal triangle all the way to the left. We're going to start with a 1. So see if you can do it by yourselves. 1, you got that one? Then 1 and 1. Now must continue with the 1 on the left. Remember, it has to be a triangle. In here, I'm going to go and add up those two numbers, and that'll give me a 2. End up always with the 1. You're going to start with the 1. Remember, we're looking for the 5th row. I'm going to add up those two numbers. That gives me a 3. Add up those two numbers. That gives me a 3. And end with a 1. Start with a 1. Add up those two numbers. That will give me a 4. Add up those two numbers. That will be a 6. Add up those two numbers, and that will give me a 4. We end with a 1. Start with a 1. Those two numbers will give me a 5. Those two numbers will give me a 10. Those two numbers will give me a 10. And last will give me in 5. And let's not forget about the 1. This to the 5th power, so we're going to be using this row. 1, 5, 10, 10, 5, 1. So let's go and write them down. There'll be a 1, then a 5, then a 10, then a 10, then a 5, and last will be a 1. Now, letter A will be 2x. Will be 2x, 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 and 2x. The exponents. Remember, we're going to start with the 5 all the way down to, from 1 all the way down to 0. Now the letter B, which will be a negative 3 in this case, negative 3, negative 3, negative 3, negative 3, negative 3, and negative 3. And don't forget to place a plus in between each one of them. And what did I forget? My exponents for the negative 3. Now the 5 went from 5 all the way down to 0. Letter B will be from 0 all the way up to 5. And now we just need to simplify each one of them. So let's go and simplify the first one. Must simplify all 3 of them. I have a 1. I need to simplify 2x to the 5th. That is 2x times 2x times 2x times 2x times 2x. So that will give you 32x to the 5th. Remember, you want to be able to write small. Now, negative 3 to the 0 power, anything to the 0 power is 1. Multiply all 3 numbers will give you 32x to the 5th plus Let's bring down the 5. We're going to simplify the next set, the next term. 2x to the 4th power will be 2x times 2x times 2x times 2x. That'll be 2, 4, 6, 8, 16. So it'll be 2, 4, 8, 16. That will give me 16x to the 3rd power. And now, negative 3 to the 1st power will be negative 3. You're going to multiply all three numbers. 5 times 16 is 80 times negative 3. 80 times negative 3 will give me negative 240 x to the power of 3. Now I'm going to simplify the next term. So I will positive 10. 2x to the 3rd power will be 2x times 2x times 2x, which will be 8x to the 3rd power. And I still have my negative 3 to the 2nd power, which is negative 3 times negative 3 is positive 9. I'm going to multiply all three numbers. 8 times 9 is 72, times 10 is 720x to the power of 3. Positive. Now let's continue to the next terms. I'll simplify this out. That's a 10, so positive 10. 2x to the 2nd power will be 2x times 2x, which will be 4x to the 2nd. And negative 3 to the 3rd power will be negative 3 times negative 3 will be 9, times negative 3 will be negative 27. 4 times 27. 4 times 20 is 80. 4 times 7 is 28. That'll be negative 108. And multiply by 10, add 0. And we have x squared. So you basically just multiply all three numbers. You can multiply 10 times 4 is 40. Times 27 will give you 1080. And remember, positive times negative will give you a negative. Let me simplify the next one. And then I'm running out of space, so I'm going to cheat a bit. I'm going to extend it. Let me multiply the next set. That gives me a positive 5. 2x to the 1st power will be 2x. And negative 3 to the 4th power will be negative 3 times negative 3 times negative 3 times negative 3. 99 is 81. So it gives me positive 81. Multiply this out. That gives me 162. Or let's see. That gives me 10 times 81 will give me positive 810x. Last, I'm going to simplify the last term. So it gives me positive 1. 2x to the 0. Remember, anything to the 0 power will give you 1. And negative 3 to the 5th power will be negative 3 times negative 3 times negative 3 times negative 3, which will be negative 243. Multiply all three numbers together, so it gives you negative 243. And that will be your answer. This will be your binomial expansion. If you expand, if you multiply this 5 times using the FOIL, you'll get exactly the same answer if you are careful enough. But this will be much easier. And yes, I made one little mistake. Did you guys catch my mistake? Somewhere in here. There you go. That should be a 4. Right? Now, one of the things that you want to make sure that you are careful is that whenever you set up your problem, the exponents should always add up to 5. So that gives you 5, 5, 3 plus 2 is 5, 5, 5, and 5. And that will always be true. Now let's go into problem number 2. On problem number 2, it says, you are assigned 7 reading assignments over the summer. In how many ways can you complete the reading assignments if you must read the story of Pi first? So that's one of the stories that you need to read. So let's go and highlight the key information. You are reading 7 assignments over the summer. How many ways can you complete the assignment if you must read the story of Pi first? Remember, we have different types of problems. We have the probability problems, we have the dashes, and we have the combination. In this case, we are kind of rearranging the way we are reading the assignments. So rearrangements, that means that we're going to have to do our dashes. 1, 2, 3, 4, 5, 6, 7. Now the story of pi has to go first, not last. It has to go first. And if it has to go first or if it has to go last, it really doesn't matter. Now, some of you guys have a problem that whenever you have a last, you start with 7, 6, 5, 4, 3, 2. No. It doesn't matter where it is. You're going to place it first. How many stories are left? 6. So it'll be 6 times 5 times 4 times 3 times 2 times 1. Correct? You have 6 stories left. So if you place one here, then you have 5 left. If you place one here, you have a total of 4 left. Then 3, then 2, then 1. Then we're going to multiply those numbers. That gives me 30. Multiply. That's 12 times 2 is 24. And times 1. 3 times 24 will give you 72. And don't forget to add your 0. So there are 720 different ways that you can read all of the stories if you read the story of pi first. Problem number 2. Let's go and read the problem together. It says, Victor wants to create a 5-digit screen name without repetition. So we have a 5-digit screen name without repetition. How many screen names can he create in this way? So we're going to end up with 5. Once again, we are selecting 5 different digits. Now remember, on your quiz, a lot of you guys are just going 5, 4, 3, 2, 1. You are looking for digits. You have to understand what is a digit. Just like we covered before, the digits are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes it says non-zero digits. So you cannot use a 0. In this case, it doesn't. So we have also the digit 0. So how many digits are available for the first spot? Let's see, 10 of them. Now let's assume that you selected one of them. You selected 3 for that spot, for your screen name. How many are available for the next one? You already took one out, so it'll be 9, 8, 7, 6. Multiply that. That gives me 90. Well, let's multiply this out, gives me 72. Multiply this out, gives me 42. And let's not forget about those 0. Now we're just going to multiply 72 multiplied by 42. Remember, on your test, you're not going to be able to use a calculator, so you should be able to do it by hand. And that gives you 28. Add them together, so it gives you 32, 0, and so your answer will be 3,024 different screen names if you want to be able to use 5 numbers, 5 digits. Let's continue to problem number 4. Remember, I'm going over the different type of problems that you guys will be seeing on this chapter, or that you have seen on this chapter. 5 teams are competing so we have 5 teams that are competing on the final round of the Olympics for a 4-person bobsled. In how many ways can 3 bobsled finish first, second, and third? So they're all in a race, and remember, the fact that it's a 4-person race, 4-person per bobsled does not matter. So we're just looking for the 5 teams. We're looking for first, second, and third. First, second, and third. It doesn't matter who finishes 4th or 5th. It really shouldn't matter who finishes 2nd and 3rd, but in this case they do ask you about it. So how many teams are available for the first spot? All 5 of them. One of them crosses the line. Shoo. Now how many of them are available for second spot? 4 of them are still behind. The second one crosses the line. Shoo. How many are available for the 3rd place? There's 3 still competing. And we don't care who finishes 4th or 5th. We multiply it out, so it gives me 12 times 5 will give me 60 different ways that those 5 teams can finish first, second, or third. Make sure you read the question carefully. Problem number 5. A factory is making a new sports shoe design that comes in 3 different styles. So you're looking for 3 different styles and 8 different colors. How many different combinations, so combinations should give you a little clue, are possible if you can only choose one design and only one color? So we are selecting. First, we need to be able to select the styles. How many styles are available? 3. And how many are we selecting? Only one design. And that's what they mean by it. They should say one style, one design. Sorry for that. Times and multiplication. How many colors are available? 8. And how many are you selecting? 1. Remember, 3 choose 1, you don't need to expand it. So it'll just be 3. 8 choose 1, you don't need to expand it. That'll be 8. So it'll be a total of 24 different designs. Now let's continue to problem number 6. Mike has 9 friends who are interested in joining his bowling league, but he only has 3 openings. How many different ways can he select 3 of them? Remember, you are looking for keywords. In this case, select, you are choosing, you are selecting, and you are selecting all 3 of them at a time. You're not selecting one and then another and then another. You're selecting all 3 of them at the same time. So in this case, it will be, how many are available? 9. How many are you selecting? It will be 3. So be expanded, 9 factorial, denominator. 9 minus 3 will be 6 factorial, and then 3 factorial. 9 times 8 times 7 times 6 factorial. That will cancel with the 6 factorial. Cancels. And then we have 3 factorial will be 3 times 2 times 1. Let's see. 2 times 1 will give you 2, and the 8 will give you a 4. 3 and 9 will give you a 3. So multiply 4 times 3 times 3. That gives me 12 times 7 will give you 84 different ways that you can select 3 out of those 9 friends that are interested to join your bowling league. Now let's continue to problem number 7. On problem number 7, it says a standard deck of 52 playing cards has 4 suits, 13 different cards in each suit. So in this case, they just give you the basic information. They tell you that there are 52 cards, 4 suits in the deck, and there's 13 different cards in each suit. All the information that you already know. Now this is the question. If the order in which the cards are dealt is not important, which usually isn't, how many different 3-card hands can you get that are all black? Now remember that you are only concentrating on the ones that you are looking for. The fact that you have 52 cards or that you have 4 suits or 13 does not matter. How many black ones do you have total? Anybody knows? So we have a total of 26. And how many are you looking for in each hand? 3. So the fact that 52 doesn't matter. We don't care about the other 26 that are red. We're only looking for the black ones. In this case, we're going to expand this. So it'll be 26 factorial over 26 minus 3 will be 23 factorial multiplied by 3 factorial. So it'll be 26 times 25 times 24 times 23 factorial. Of course, you don't need to go all the way down. That will cancel with the 23 factorial. And 3 will be 3 times 2 times 1. Let's see, this 2, that will give me 6. Cancel with the 24 and gives me a 6. So let's multiply all 3 numbers together. I'm just going to do it on a little piece of paper on the side. And if you want to do that on your homework, that's fine. Just get a little notepad and just multiply 26 times 25. That is 30, carry 3, 10, that'll be 13. That's 12, carry 1, that's 4, that's 5. That's 0, 5, 6. 650 and multiply by 6. 0, 30, carry 3, 36, 39. So it'll be a total of 3,900 ways that you can get three cards that are all black. Problem number 8, it says, Laura has moved to a new apartment. She has 3 math books, 7 English in her backpack. If Laura opens her backpack and selects 5 at random, what is the probability? Now remember, that's the word that you're looking for. Probability, that means that you're going to be having a fraction. Now the question is she selecting one and then another and then another and then another and then another, or is she selecting all of them at once? So it's a 1, 1, 1, 1, 1, 1, or all of them at once. In this case, she's selecting them all at once. So we have to use the choose. Probability that she has 5 English books will be first on the numerator. How many English books do you have total? 7. And how many do we need to select? 5. On the denominator is all of them. How many different ways can you select 5? Doesn't matter if they're math or English. So how many books total? That'll be 10. And how many are we selecting? 5. So we just simplify each one of them. So let's see. That'll be, on the first one, will be 7, choose 5. Will be 7 factorial over 7 minus 5 will be 2 factorial and 5 factorial. And we just expand it. So it'll be 7 times 6 times 5 factorial. The 5 cancels with the factorial. And then we just have 2 times 1. That gives me 3. So that gives me a 21. Denominator. 10, choose 5. So it'll be 10 factorial. 10 minus 5 will be 5 factorial and 5 factorial. So it'll be 10 times 9 times 8 times 7 times 6 times 5 factorial, which will cancel the 5 factorial. And then we have 5 times 4 times 3. Let me expand this. Oh, you guys can't see. Sorry for that. There we go. So in this case, we have 6 and 5 factorial, which cancels with the 5 factorial. And 4, 3, 2, 1. So now let's simplify. The 4 and the 2 gives me a 8, so that cancels. The 3 and the 6 gives me a 2. The 5 and the 2 gives me a 2. So therefore I have 2 times 2 is 4. 28 times 9. So 28 times 9, that'll be 72. Carry 7. 18, that'll be 25. So it'll be 252. 252. Just be careful. I'm going to give you guys scratch paper on the test so you guys can actually expand it all the way through. And you can do this on a separate piece of paper and just attach it to it. That's not a problem. Now, if you're not sure if you can reduce it, that's fine. I mean, you should be able, because the numbers 2, 5, and 2, they add up to 9. I know that it should be able to be divisible by 3. But for now, let's just leave it like this. It's not a problem. Ideally, you have a calculator, you can change to a decimal and then to a percentage. Problem number 9. On problem number 9, it says a bag contains 7 pencils and 3 ball pens. Ronald is taking one random object from this bag, places it back in his pocket, and then selects another. So remember, in this one you're selecting one and then another. What is the probability? Probability means that you're going to have a fraction, that it takes two pencils out. So we have the probability of a pencil and a pencil. What's the probability of getting the first pencil? Even though the first time you're only taking one, we have to think, how many pencils are available? 7. How many writing objects are total? 10. Times. What happens to the pencil? He places it in his pocket. So second one will be 6 out of 9. So we're going to reduce. We're going to divide it by 2. So it gives me a 3. Gives me a 5. I'm going to divide that 3 and the 5. Divide by 3 gives me 1 and gives me a 3. So that gives me 7 over 15. Remember, you want to be able to reduce before you multiply it out. In last review question, it says, find the variance and standard deviation. So first, I need to find my mean. Remember, you cannot use a calculator, so you need to show me all of the work, even if you do it on a separate piece of paper. That gives me 19. That gives me 26, and then 10. 15 carry 1. That gives me 55. So 55 divided by 245, which is 11. That is my average. That's my mean. Now to find the standard deviation, I have to do 11 minus 7 will give me 4 square, plus 11 minus 12 will give me 1 square, plus 11 minus 12 will give me 1 square, plus 11 minus 10 will give me 1 square, plus 11 minus 14 will give me 3 square, and divided by 5. Standard deviation will be 16 plus 1 plus 1 plus 1 plus 9 divided by 5. Standard deviation will give me, that gives me 10, 11, 12, and 16 will give me 28 divided by 5. So standard deviation will give me 20 divided by 5. You just do the long division. 5, 25, 3, 6. 5.6. Now your variance is 5.6. Your standard deviation, you have to take the square root, which is about, square of 4 is 2, square of 3 of 9 is 3. So you can just give me 2.5. That'll be perfect. Variance is before you take the square root. Standard deviation is after. So your homework will be to complete the backside. And I apologize, I know you guys are disappointed because I only gave you guys a few problems to do for homework. But that will help you guys catch up for any of you guys that are falling behind. Have a great day, and I'll see you guys next time.